The AI model is breaking on the inside, long before it fails on the outside. In a high-stakes production environment, fully fine-tuning a major AI model isn't just risky, it's reckless. You're gambling a multi-million-dollar asset to teach it one new skill. There's a remarkable irony in AI right now. We're building AI models so smart, it's almost breathtaking. They feel like the future. And yet, deep down, they carry a surprisingly simple, almost primitive flaw. These models can write poetry, argue philosophy, generate perfect code. They are incredible feats of engineering. But the moment we try to fine-tune an AI model and teach it something new, the whole system can fall apart. And here's the crazy part. It's not a bug. It's just how they learn. They literally overwrite their own knowledge. The official term is catastrophic forgetting, but I think digital amnesia captures it better. And if you're using AI in your business, this isn't a quirky flaw. This is a serious liability. So, in this video, we're going to tackle why fine-tuning AI is broken and what actually works instead. First, we'll diagnose what is actually breaking inside these models during fine-tuning. Then we'll cover the elegant engineering solution that's taking over the industry. So, what's behind this AI memory problem? The answer is completely counterintuitive. Here's the paradox. You'd assume that fine-tuning an AI model on a task similar to what it already knows would be easy. It should reinforce the learning. But the data shows the opposite is true. The more similar the new task, the worse the AI model forgets. This isn't just a hunch. Researchers found a Pearson correlation of 0.87 between task similarity and memory loss. For anyone who works with data, a number that high isn't a hint. It's a flashing neon sign. Similar tasks aren't helping each other. They're competing for the same brain space. The culprit has a name: gradient conflict. When a model learns a similar new skill during fine-tuning, it tries to force that knowledge into the exact same neural circuits as the old one. It's like renovating your kitchen by tearing out all the load-bearing walls. The damage isn't cosmetic. And that structural damage follows a very predictable three-stage cascade of failure. First, the model's attention mechanism, its core ability to focus and understand context, gets disrupted. Second, its internal map of how concepts relate to each other starts to drift. Third, the actual foundation where knowledge is stored begins to collapse. This whole battle kicks off deep inside the model's attention layers. And the data here is just wild. The conflict rate inside the query and key projections, which are essential for understanding context, is a whopping 67%. This just goes to show that the forgetting isn't random. It's like a targeted attack on the most vital parts of the AI model's brain. Now, to understand the final stage, the most dangerous one, picture this. In a healthy model, a concept is like a marble sitting in a deep, steep-sided bowl. This is called a sharp minimum. Shake the table, and the marble rolls right back to the center. The knowledge is stable. Aggressive AI, fine-tuning, flattens that deep bowl into a dinner plate. Now the smallest nudge sends the marble rolling off, with nothing to bring it back. The knowledge becomes scattered, unstable, and the AI model hasn't just forgotten a fact. The pathway to remembering it has been completely erased. This is catastrophic forgetting in action, and it follows a predictable timeline. During the first 1 or 2 training cycles, the damage is happening internally, and performance still looks fine. Around epochs 3 to 5, accuracy starts to decline. By epoch 4 and beyond, the landscape has flattened, and the damage is permanent. Here's the kicker. The model is breaking on the inside long before it fails on the outside. In a high-stakes production environment, fully fine-tuning a major AI model isn't just risky, it's reckless. You're gambling a multi-million-dollar asset to teach it one new skill. So, if fine-tuning AI is broken, what actually works instead? There's a family of techniques called PEFT, parameter efficient fine-tuning. And the core idea is brilliantly simple. You take your large pre-trained model and you freeze it. All of its core knowledge becomes read-only. Then you attach a small set of new parameters, less than 1% of the model's total size, and you train only those. It's like swapping the tires on your car instead of rebuilding the engine from scratch. Comparing parameter-efficient fine-tuning versus full fine-tuning. Full fine-tuning touches 100% of the model's parameters. The compute cost is massive, and the risk of catastrophic forgetting is high. PEFT trains a tiny fraction, cost drops dramatically, and the risk of AI forgetting essentially disappears. It's just a fundamentally smarter, safer, and more scalable way to work. The numbers back this up. Methods like LoRa can match the performance of full fine-tuning while training 95% fewer parameters, with up to 90% savings on compute costs. This is the technology making it possible to run powerful custom AI, not just in huge data centers, but right on your phone. But here's the thing. Parameter-efficient fine-tuning is more than a clever engineering trick. It represents a shift in how we think about AI entirely. We're moving away from AI models that constantly overwrite their own knowledge towards systems that can genuinely accumulate knowledge and grow over time. Humans don't suffer from catastrophic forgetting. We learn to ride a bike without forgetting how to walk. We layer new skills on top of old ones. That is the goal for artificial intelligence. And for the first time, because we understand why AI forgets, and we have the tools to prevent it, that goal feels genuinely reachable. We are learning how to build AI systems that evolve instead of just replace. Because getting this right isn't an academic exercise. It's the difference between disposable models with a limited shelf life and truly intelligent systems that can learn, adapt, and grow right alongside us into the future.